Huawei may be assembling something no other Chinese tech company has ever controlled at this scale. The processor, the memory, the storage, the software, and possibly even the factories producing the most critical chips inside its own devices. That matters because Apple, despite designing some of the most advanced consumer processors on Earth, still relies on outside firms for the memory and flash storage inside every iPhone, iPad, and Mac. Huawei, by contrast, seems determined to shrink that kind of reliance as much as it possibly can. Music, the latest reports center on DRAM, the fast-access working memory used in smartphones, computers, servers, vehicles, and nearly every modern electronic system. Huawei hasn't confirmed that it owns or runs a DRAM manufacturing network. In fact, it has pushed back against claims that it secretly controls a hidden cluster of semiconductor plants. Music, but analysts, industry publications, corporate ties, and earlier satellite investigations keep pointing toward a far tighter relationship between Huawei and several Chinese chip firms than the official ownership paperwork suggests. One name now drawing heavy attention is Suisure, a Shenzhen memory company linked to a planned 12-inch DRAM facility. Reports describe a production target near 140,000 wafers a month, though that number is still unverified. If the plant ever gets close to that scale, this wouldn't be a lab experiment. It would be industrial-grade capacity built to supply enormous volumes of memory for Chinese phones, computers, servers, networking gear, and more. That's where the story stops being just another new semiconductor factory. Huawei already develops its own Kirin processors through HiSilicon. It sells enterprise SSDs and storage systems, and has spent years building proprietary SSD controllers, storage software, and flash management technology. Music. It also builds phones, computers, networking hardware, cloud infrastructure, vehicle systems, and data center equipment. Add a dependable domestic DRAM source, and those separate pieces could fuse into one unusually integrated technology platform. Apple is often called the master of vertical integration. It designs the iPhone, its operating system, the processor architecture, many supporting chips and surrounding services, control that produces excellent performance because hardware and software are tuned together. Music, but Apple doesn't fabricate its own leading-edge chips. TSMC does. It doesn't make its own DRAM either. Samsung, SK Hynix, and Micron supply that memory. Apple also leans on outside firms for NAND flash and plenty of other essential parts. Huawei's ambition looks different. It isn't merely chasing the best phone processor or the most polished OS. It's trying to build a supply chain able to keep running even when foreign governments cut off access to key technologies. Music. In that kind of environment, owning more of the stack stops being just about performance or margins. It becomes a form of strategic insurance. Washington put Huawei on the entity list back in 2019, sharply cutting its access to American technology. Later export rules also restricted foreign-made chips built with certain U.S. software or tools. Those measures gutted Huawei's phone business, weakened its access to top-tier processors, and forced the company to hunt for alternatives at nearly every level of chip development. For years, plenty of observers assumed the restrictions had permanently stalled Huawei's momentum. Global phone shipments collapsed, Google services vanished from new international devices, and advanced chips became hard to source. Music. Then Huawei came back with premium smartphones running domestically made Kirin chips. Those processors didn't immediately match the top Apple or Qualcomm offerings, but their mere existence showed China's chip ecosystem had advanced further than most outside analysts expected. Now the next frontier may be memory. The timing matters because memory has turned into a geopolitical commodity, not just an ordinary one. Washington is debating how to treat Chinese DRAM, while Beijing keeps pushing domestic substitution across strategic supply chains. Music, a Huawei-linked memory project, would serve two goals simultaneously: feeding commercial products while insulating critical Chinese hardware from future restrictions imposed unilaterally from abroad. A processor grabs most of the attention because it does the calculating and carries the recognizable brand, but a processor without memory can't do much useful work. DRAM temporarily stores the data a processor needs right away. Faster memory sharpens responsiveness, multitasking, gaming, professional software, and the efficiency of large computing systems. When memory is scarce, pricey, or restricted, even a powerful chip becomes hard to deploy at scale. Huawei currently sources memory through suppliers and partners like most tech companies. China's strongest established DRAM maker is CXMT, which has expanded fast and is now squarely in Washington's political crosshairs. American lawmakers have floated tighter limits on Chinese memory chips, especially given reports that major global firms have already evaluated Chinese components. Music. That pressure gives Huawei even more reason to back an alternative source. If Shueisha can churn out usable DRAM at scale, Huawei gains a second domestic pathway. It could shape memory specs around its own processors, storage systems, phones, servers, and networking products, coordinate product development earlier, test components more closely, and lower the risk that a foreign supplier suddenly disappears because of sanctions or licensing decisions. Still, building DRAM is brutally hard. Memory chips look repetitive next to complex processors, but manufacturing them profitably demands enormous precision, strong yields, advanced materials, reliable equipment, and years of accumulated process know-how. Music. A factory can technically make working chips and still lose money if too many wafers come out defective. Samsung, SK Hynix, and Micron spent decades refining production and spreading their research costs across massive global businesses. The reported Shueisha facility is tied to 28-nanometer DRAM technology, a number that sounds ancient next to the small node figures used in market processors. But memory processes can't be compared directly with logic processes. Mature equipment can still turn out valuable memory for industrial devices, networking gear, cars, consumer electronics, and countless other products. The first goal here likely isn't beating the newest Samsung memory chip. It's building dependable capacity, using tools China can obtain, maintain, and eventually replace on its own. This is a familiar playbook. Start with what's achievable today. Use domestic demand to keep factories running. Improve yields through repetition. Train engineers. Localize more equipment and materials. Then push toward higher density, lower power draw, and more advanced memory generations. Huawei has the scale to sustain that process. According to its 2025 annual report, the company pulled in 880.9 billion yuan in revenue and poured 192.3 billion yuan back into R&D, more than a fifth of annual revenue. Huawei also reported roughly 114,000 employees working in R&D by the end of 2025. Few companies anywhere can sustain that level of engineering investment. Money alone doesn't guarantee success, but it shifts the odds. A smaller firm might walk away from a punishing semiconductor project after a few years of losses. Huawei can spread the cost across telecom, consumer devices, enterprise storage, computing, automotive tech, and energy products and services. It can even become the first customer for its own components, giving new factories demand before they're competitive on the open market. One of the biggest perks of vertical integration. Picture Huawei engineering a new processor for a future phone. If it also has a hand in the DRAM, storage controller, SSD firmware, operating system, and device design, its engineers can optimize the whole system instead of waiting on standardized parts from unrelated suppliers, trimming power use, boosting data transfer, tweaking packaging, or building in features tailored specifically to Huawei products. Samsung is the clearest existing example of this model. It designs processors, fabricates chips, produces DRAM and NAND flash, builds displays, assembles phones, sells appliances, and runs enormous factories. It doesn't control every component in every product, but its manufacturing depth gives it options most rivals simply don't have. Huawei appears to be steering toward a Chinese version of that broad industrial structure, though it remains well behind Samsung in advanced memory production and manufacturing experience. The Apple comparison is trickier. Apple's business model doesn't need its own chip factories. It uses its purchasing muscle to lock in leading-edge production from specialized suppliers while pouring its own resources into design, software, product integration, and services. That model has worked spectacularly well. Apple gets access to TSMC's newest manufacturing without shouldering the cost and risk of running fabs itself. But Apple's model assumes an international supply chain stays open. Apple can negotiate with suppliers, spread out orders, and reserve huge production runs, but it can't directly command a factory it doesn't own. Huawei has already lived through what happens when political decisions suddenly sever those relationships, so it may be willing to accept higher costs and less advanced tech today in exchange for more control tomorrow. None of this means Huawei is already self-sufficient. It still depends on outside firms, imported equipment, specialized materials, manufacturing partners, and technologies China hasn't fully replaced. Even its most advanced domestic processors have been tied to SMIC rather than fabs Huawei openly owns. Semiconductor manufacturing equipment remains a real weak point, since the most advanced lithography, inspection, deposition, and testing systems sit with a small handful of foreign suppliers. There are also real questions about the reported 11-fab network. Industry reports describe factories connected to Huawei through employees, financing, customers, technology transfers, or local government backing. But indirect ties aren't the same as legal ownership or operational control. Huawei denies running a secret fab network, and public evidence doesn't let outsiders verify every claim. Any fair reading has to separate confirmed Huawei products from alleged manufacturing links. What's confirmed is the direction Huawei is heading. The company openly develops processors, computing systems, enterprise SSDs, storage controllers, networking chips, operating systems, and full hardware platforms. In May 2026, Huawei unveiled a new chip design strategy built around advanced packaging, architecture, software, and system-level coordination, rather than leaning solely on smaller transistors. It also said future Kirin chips would use a logic folding architecture to boost performance through tighter integration. That approach shows how Huawei plans to compete while its access to most advanced manufacturing stays limited. Instead of waiting for Chinese factories to replicate every piece of the global supply chain, Huawei is redesigning products around what it already has. Multiple chiplets can be linked through advanced packaging. Software can schedule workloads more efficiently. Larger systems can combine many processors. Memory, storage, networking, and computation can all be coordinated as one platform. DRAM fits naturally into that vision. Memory, bandwidth, and latency become bottlenecks once processors are stitched into bigger systems. A company tied to an external memory roadmap has less room to maneuver, while a company that influences both sides can experiment freely with packaging, interfaces, capacity, and power targets built around its own products. The same logic extends to storage. Huawei already sells Ocean Disk Enterprise SSDs and Ocean Store all-flash systems, with public materials describing proprietary SSD, controller tech, and end-to-end storage development. But selling an SSD doesn't require fabricating every NAND cell inside it. The strategic aim isn't instant ownership of every atom in the device. It's steadily gaining control of the most important designs, controllers, software layers, suppliers, and production routes. For China, Huawei's expansion could also lift a wider domestic ecosystem. A DRAM facility needs wafer equipment, photoresist, gases, chemicals, masks, testing tools, packaging services, and trained engineers. Even if the early chips lag behind foreign competitors, every production run builds experience for local suppliers, and that industrial learning can spread to other companies, making future restrictions less effective over time. For foreign competitors, the immediate danger probably isn't Huawei grabbing global market share with the world's fastest DRAM. The bigger danger is Huawei becoming much harder to pressure. Sanctions work best when a target depends on something only outsiders can supply, and every domestic processor, memory chip, controller, production tool, and software platform removes one more point of leverage. This could reshape competition inside China first. Huawei could favor its own components, steer large orders toward affiliated suppliers, and bundle processors, memory, storage, networking, and software into complete systems. Chinese buyers wanting stable domestic supply may tolerate lower efficiency or higher prices, especially in government, telecom, infrastructure, and other strategically sensitive sectors. Over time, scale could shrink those disadvantages. More orders finance better equipment, higher volumes improve yields, bigger engineering teams solve defects faster, and suppliers gain the justification to develop specialized materials. What starts as an expensive sanctions workaround can eventually harden into a genuine competitive industrial base. Still, nothing here is guaranteed. Memory markets are brutally cyclical. Prices can crash when too much capacity floods in, and established producers can slash prices, accelerate investment, and use their technological edge to squeeze out new rivals. Huawei and SMIC would need to prove they can manufacture DRAM not just once, but reliably, efficiently, and repeatedly across multiple generations. There's another risk, too: harsher American restrictions. If Washington concludes Huawei is using affiliated companies to obtain restricted tools or technology, more firms could land on export blacklists, and SMIC has already faced serious American scrutiny. Expanded controls can make equipment maintenance, software updates, spare parts, and future factory expansion far tougher. But restrictions cut both ways. In the short term, they slow production and raise costs. In the long term, they can convince a large country that dependence itself is intolerable, and Huawei's current semiconductor strategy is a direct result of being severed from suppliers it once treated as ordinary business partners. The more pressure mounts, the more resources China may pour into replacing every vulnerable component. That's why the real story here isn't whether one rumored factory instantly outpaces Samsung or Micron. The real question is whether Huawei can knit together enough domestic capabilities to form a self-reinforcing technology system. Huawei processors generating demand for Chinese fabs, Chinese memory supporting Huawei devices, Huawei storage products driving demand for controllers and NAND, and domestic equipment makers learning from every new production line. Apple's ecosystem draws its power from millions of customers, developers, devices, services, and custom chips reinforcing one another. Huawei is attempting something different, an ecosystem built not just on software and consumer loyalty, but on industrial survival. It wants the device, the operating system, the processor, the networking, the storage, the memory, the packaging, and eventually more the machinery underneath all of it. In my opinion, Huawei is still years from true semiconductor independence, and some claims about its hidden factories may be overstated. But writing off the strategy just because its first products trail the competition would repeat the same mistake many observers made before Huawei's smartphone comeback. The company doesn't need to lead right away. It just needs to keep producing, learning, improving, and stripping away one dependency at a time. If Huawei eventually locks down reliable supplies of CPUs, DRAM, SSD technology, and advanced packaging, America will be facing a far tougher target than the company it sanctioned back in 2019. Apple may keep building faster, more profitable devices, but Huawei could end up holding something increasingly precious in a divided world: the ability to keep building even when outside suppliers are ordered to stop. So, what do you think? Is Huawei building the next Samsung-style semiconductor empire, or will manufacturing limits keep it from closing the gap with Apple and the world's leading chip makers? Tell us your take in the comments. And for more on China's processors, memory, storage, manufacturing, and the global tech race, subscribe to the Eastern Engine channel.